Ba-da-ba-da-ba-da-ba. That's the beat. Hello, everybody. Welcome to Adafruit Show and Tell. It's a show where we are hosting, but this is where we invite folks from the community to come on and share your projects, whether it's 3D printing, biohacking, whatever type of making,
3D printing,
retro tech,
software,
long list of things, all the things. We're going to start off with folks from the community, from Adafruit, and then the community.
Take about like a minute or two. And if you want to join, get up on discord.gg/Adafruit where you'll see the link to get up on the show and tell. First, going to start off with Brent Rebel.
Brent, where are you? There you are.
Hey, guys.
Hey.
So the past week, we have some exciting stuff to show for Adafruit.io. So this is a collaborative effort between me and Melissa. And she worked on the website of things, and I worked on the hardware side of things. And now if you have an ESP32 board, so like the Feather ESP32, I'm also starting to play around with some of the Sonos switches that are really, really inexpensive. Like the mini ones are pretty cheap too. You can use it with Whippersnapper. And what's really neat is that you don't need to install anything. So you plug in your board. And if you've seen ESP Web Tool, which Melissa also worked on, this uses the Chrome browser as a serial connection. So you select this doesn't show it on StreamYard, but it shows it on mine, and you select the board and it attempts to reset the board, and maybe it doesn't. Awesome. I love demos. All right. And then it connects to it. So then you enter your SSID, your password, which is, I just changed it like 2 minutes ago. And then it has the script on it already, your Adafruit.io username, and I just generated a new password. And then you just click install Whippersnapper. And what it does is it erases the flash, and then it installs your credentials into the non-volatile memory section of the ESP32. And this is a really interesting way of provisioning devices, because previously, like if you were using a Feather and it was like in the field, right? Like you make a sensor node and you install it, and there was a person who was like installing it literally near a volcano on Adafruit forums, and he was like, I gotta wait like 3 weeks to get back to the volcano. Wow. This is a way of doing things. This is an OTA, but this is a way of doing things where you don't need somebody with an IDE and experience with Arduino or experience with anything but like the internet. So you should be able to, like if you're an educator and you're bringing boards to and from a classroom, you can only update your credentials, or you want to flash it to use a different user's board and a different credentials, you can do it from here. And like unlike other IoT platforms, there's no agent that needs to be run on the computer itself. It's all run in the Chrome browser, which is really nice. It takes like 86 seconds about, and should be done in a little bit. Yeah, and then when it's finished, it will disconnect from this, and it will pop up on Whippersnapper and say, I'm an ESP32. So I'll give it like a few seconds.
You can try like
the beat you guys did earlier.
Yeah, no, that was whack, man.
Yeah,
that was me trying to do a beat.
Yeah. All right, there we go.
Yay.
And then it generates the NVS, and then it's done. So if you reset the device, like I'll just physically press a button. The device on my desk is glowing, and then it checks in to Whippersnapper. It says we have a new Huzzah 32, and you can name it. And it shows the firmware version it's running now as well. Yeah. And you're all set, and then you can add components to the device. Yay. So this is a new thing, and if you want an invite for it, go to the Adafruit Discord, which is adafruit.it/Discord, and go to the Help with Adafruit.io channel, and just type, I want an invite to Whippersnapper, and I'll take care of it. Don't message me directly. Just type in that channel, and I'll take care of it.
All right.
Well done.
So cool. So when do you think like a wider release beta will be out?
End of this month, I hope.
Oh,
we're pretty close.
Yeah.
Okay. Awesome.
Yeah.
Well done. This is a great.
I'll say it on air. Like that's what I'm looking at.
Okay. Cool.
All right. Can't wait to try this out. It's so cool.
Yeah, man.
Awesome.
All right. Well,
glad
thanks,
you're
Brett.
excited. Thanks all.
Yeah. We'll see some more stuff later on. All right. Cool. Next up, we're going to jump into Kevin. Kevin. Hey, Kev.
Hey, how are you guys doing? Good to see you.
Yay.
Happy Wednesday. Happy show and tell day.
Yeah, for sure.
So, couple things. First thing that I was working on my demo for Sensors Expo. And this thing is really cool. This is called a phase dock. You can get these at DigiKey. There's different slides and holders for different boards and make it for all sorts. And this one, I'm doing a demo on the Adafruit Stemma QT and all the different peripherals and sensors. I can get a little closer to it. But you can either zip tie. Yeah, you can zip tie it to the board, and it's got a clear plastic cover. You can throw this in a backpack. These are great for schools or anybody that's doing. I've seen so many cool projects on here on Show and Tell, and if you want a way to keep it somewhat portable and safe and together, these things are really cool. So check them out on DigiKey. And the other thing I wanted to bring up is our Halloween contest on Hackaday.
There it is.
And yes, and there it is. So Halloween Hackfest. And there's again so many cool projects that I see on Show and Tell. So go put these Halloween projects on Hackaday and enter your chance to win. The prize, if you use an Adafruit board, is doubled. So that's pretty exciting.
Yeah, that's awesome. Yeah, there's some contest entries as well.
Yes.
There's 3 projects right now, so you have plenty of time. I think the deadline was October 11th, if I'm not mistaken. So there's plenty of time to get in on it now. But yeah, if you haven't already, sign up to Hackaday.io. It's free to do so, and you can start posting up your photos of your projects.
Yeah, definitely time to get started right now, so you don't have that excuse of no, it's too late.
Or it's too late. Yeah.
Yeah, the one that
Halloween is year round.
Yeah,
it sure is.
Yeah, the coolest one I think is this.
Halloween can be always.
Yeah, I think this skeleton one, if you guys want to get some inspiration, is really cool. It's adding a motor to one of those 12-foot skeletons that sort of blew up. Everybody's getting
from Home Depot. Yes, these are amazing.
I play the audio, but it's like the Pirates song.
Yeah, from Disney. we don't want to get copy strike.
But yeah, definitely check it out. It is at Hackaday.io.
Yeah, you just make your project, and then on the sidebar, there's a thing you click add to submit to the contest.
How cool.
Very, very cool. Well, thanks, guys. Happy Show and Tell day.
Thank you. Yeah, we'll see you next time. Bye.
All right, bye.
All right, next up, we're going to jump in with John Park. John. Hey, John.
Hey guys, how you doing?
That's good. How you doing?
All right, here we go. So I've got a couple projects that I've been doing using this little snap-apart PCB keyboard. So this is for mechanical key switches. I ought to have some around here. Here's a couple. I'm going to wander off for a second. So these are hot swap sockets that you can plug the key switches into, and they are connected as a diode matrix with columns and rows. And there's a NeoPixel snaking its way through here, but you can snap these apart where the little sort of nibble perforations are, either to just reduce the size down or to reconnect it in a different configuration. So last week on my show, I was working on this, and I just published the guide. This is I'm calling it the NumPad 2000. Or no, 4000. It's twice as good. And the neat thing with this one is that I've taken things off the grid. So you can see these keys here are all 1 unit size, 1U. But I wanted to use the big honkin' plus, enter, and 0. So that means that there's some snapping apart and reconfiguring and resoldering that goes on. I left the back open so we could just see that. You probably want to make a version with that covered if you're really using this in a typical spilling your soda all over the place kind of environment. But this, you can see and hear some of the wiring that goes on to kind of keep the NeoPixel strand flowing through. That's that white line. There's some ground that's being connected, some voltage, and then the yellow here are some columns, and there's some blue for some rows. So that one, the guide will show you how to set all that up. And you can see here I've got a nice big Feather RP2040 here that these are connected to. Kind of hidden up under there. And this is one of the reasons I chose this is I do have quite a few columns and rows to deal with, so I needed a decent amount of GPIO. However, what I'm working on next is a 4x4 keypad. So this one stays on the grid. This one uses our super cool aluminum case that we're selling now. It's an aluminum case. It has I think it's an aluminum plate, might be a steel plate, for the key switches to snap into. Your NeoPixel board fits in there. And then since I had already done this sort of external big honkin' board one, I really wanted to challenge myself to fit everything inside this case because it's a pretty case. So I've got a Cutie Pie in here. This is a Cutie Pie M0, but you could also do this, I think, with the Cutie Pie RP2040. It should fit. It's really, really very little clearance in there, but I found a way, and so I'm going to be showing that off on my show tomorrow, and I'll be writing up a guide on how to make your own. This one is running Arduino and just a keypad demo right now, and I set it up to do some NeoPixel stuff when you press the keys. It's nice and clicky. Some big jade switches in there. But I was issued a challenge by Lamore just a half hour ago. She said, hey, maybe you can get QMK working on this, which is a really popular keyboard management software for microcontrollers or firmware for microcontrollers for people who are making custom keyboards. So maybe that's the next step with this. And I think that's it. That's what I've got. And you can come on by tomorrow to see how this works and what's going on in here and how that possibly could fit in there.
How freaking cool.
And congrats on 200 episodes.
Thank you. Yeah, my 200th episode tomorrow. Can you believe it? The time flies.
Yeah, we're going to be having cake for you.
Yay, cake. Come on by.
Like everybody is.
Yeah, excellent.
For sure.
All right,
Thanks so much for
JP.
sharing.
See you tomorrow.
Thanks,
See you guys.
Next up, let's see what Scott's working on.
Hey, Scott.
Hello.
There we go.
Yeah. So I'm diving into USB. We had this bug for CircuitPython 7 that says, hey, the TNC just doesn't work at all. Well, it kind of works. The CircuitPython code works, but the USB side doesn't work. So I have been digging deep into the weeds of USB. And what you have here is this is a capture of all of the traffic on USB.
Wow.
And all these red lines are the ones where the protocol analyzer thinks it's incorrect. So basically what I'm doing is I'm taking a look at these red lines and trying to figure out why CircuitPython is not responding in the way that would make sense. So if things work well, you get this like higher level protocol description of like, this is getting the device descriptor. And then right after that, you can see that, oh, it does a second thing and the second thing fails. So I'm on my way. But it's very deep. So I think I'll plan on covering it on Friday for my deep dive. If people want to see me hammering on USB, I think I figured it out so that I can have like all my cameras on different USB buses. Because the danger in showing USB is
I was gonna
like,
say, yeah,
you break your USB bus, like it can be really bad for audio and video and all that sort of other sort of stuff.
Tightrope walking. Oh my gosh.
Yeah, so we might give that a try. Folks have been really patient with me if I've had technical troubles during my deep dives. So thanks to everybody for that. And I just wanted to say, I also wanted to say, hey, it's been 5 years that I've worked for Adafruit.
Yes. I think to the day when you went on Show and Tell and you got the email from PT.
Yeah, so it's been five years since I got the email from Phil, which is the day after I was on Show and Tell. But I've been doing Show and Tell a long time, and I'm happy to be here and happy to be working on CircuitPython for Adafruit.
No, I'm glad you came on to say that because it's a good reminder that coming on the Show and Tell, it's pretty much like a honeypot. This is where we find a lot of the people. I mean, that's how we got onto.
Totally, yeah. It's a great place to show your work. Sure. Even when it's USB that's not working.
It eventually gets there.
Yeah, we'll figure it out.
Cool.
All right. Awesome. Hopefully it won't take me weeks. That's the real thing.
All right. Well, thanks so much for showing up, Scott.
Yeah,
and we'll have cake for you as well. Yeah. I think we're gonna have like a bunch of little cakes for everyone.
Yes.
All right. Don't forget to exercise too.
Yeah. Oh yeah. Oh, this dog does not let us forget that.
Good. All right, Scott. Awesome. We'll see you next time.
Have a great one. Thanks.
Bye. All right. Next up, we're going to check in with the community. We have two folks here. Edicio, we got you here. Edicio. Hello.
Hey. Hello. Sorry.
Hey.
So me and my father made another project together.
Okay.
It is an Arduino.
Sweet.
And it is like 5 volts. We did not. We did make some changes in the project. Like we put. I can show in the camera, but we added some pins to connect the the cable for the energy, so you can connect it in a place that is close to this cable here. So you just put the pins here in this direction. You see? I soldered probably most of the parts, but my father soldered some of other components, and in a few weeks probably we will be doing another Arduino, and we will buy the 5 PCBs, but we will make the changes and make it.
Oh no! Get some PCB
other Arduinos. So I hope you like it. It's standard project, nothing very special, but we like it a lot to do.
Awesome. That's great. Yeah. It's always great to collab with your folks.
Yeah. Definitely post the link in the Discord if you can. Awesome. Yeah. Thanks so much for sharing.
All right. And come back and show us more projects.
Yeah. To get the revs out.
Yeah.
Awesome.
All right, Lucio.
Thanks.
Bye.
Bye.
Cool. All right. Next up, we'll jump in with Gary. Hey, Gary.
Hey, guys. Just early morning on Thursday morning in Australia. So,
wow.
Everyone.
Awesome. Hey.
So just on, I showed off a Tron project before, and I'm just showing off another version. You know, the light cycle baton.
Yes.
So I made both a black version, and I know this is out as a toy, but I thought I'd add some electronics magic, and I did a white version as well.
Nice.
So I printed off the center section using a resin printer. So there's some nice detail, and you know what's a good prop without some electronics magic? I just added a small little cap touch at the back, and just touching it off. It just sets off this circuit. And depending on which faction you're part of, you know, you just go red if you want, or amber. And I just threw in some green as well, just to, you know, because we can.
Oh, cool.
Yeah.
And off. And there we go. Great. So I just thought I'd show it off. I know the toys out there, but I thought, you know, you can always just do something so extra cool with using some Adafruit microcontrollers and some NeoPixels. So yeah, that's it from me.
I always encourage people to remake it, because the toys like that are manufactured aren't always as good as something you could make yourself.
More detail,
awesome. Right? And I love the light cycles.
The light cycles in the background are touching.
Yeah, I just thought it's my workshop's a bit of a mess. I thought I'd throw it in there.
That's great.
Thanks, guys.
Thanks, Gary.
Thanks, Gary.
All right. Next up, we'll check in with Carl and Chelsea.
Hey, guys.
Hello.
Hey.
Hello.
Hi, I'm Carl. That's Chelsea.
Hey, how you guys doing?
Good. We're in California. We have smoke.
Oh, no.
Yeah, but at least no rolling power outages yet.
Oh, that's good.
We're at a small semiconductor company in Silicon Valley. We do analog chips, and Chelsea's my intern for the summer. And we've been using your boards to demo our evaluation kits. So we recently came out with a line of RGB drivers that has some unique attributes that give it some nice advantages for people. And this is like one of our demo boards right here.
This one uses the Feather RP2040. And it was programmed in, I don't know why the light's on. It was programmed using MicroPython.
So it's on the back side. So we did a diffuser where you can see it from the front or the back.
Sweet.
And
excellent.
We have a software script in there that runs for about 7 minutes in a loop to demo all sorts of patterns and colors and crazy stuff, more than any product would usually ever want. But what we did is we made a library of functions to do different patterns. There's a couple, I mentioned we had attributes that are unique. So these are current sync regulators with switches to the high side. That basically we use Charlie plexing, and I think Adafruit is probably one of the few companies that knows what that is. So it's Charlie plex, so we have very few wires going, PC board traces going to the LEDs themselves.
Nice.
We basically use 12 wires to do 12 RGBs on this product.
Oh, wow.
And so it's 3 4-wire buses. It's actually kind of unique because we don't Charlie plex fully, and there's some technical reasons. This is how the PC board is designed. So you can see that we have the little 3x3 chip, and then there's 4-wire buses, each going to 4 RGBs. And so the idea here is it minimizes your routing. So we get a lot of customers say, oh, we used to use a lot of wires, a lot of layers to do it. And it kind of started by us dissecting the Amazon Dot. It has a chip from somebody that you guys have used on your webpage. And it's a 5x5, and we did a 3x3 that does everything and more. That was one thing.
How cool.
And so it's, third the wires, third the chip size. Size translates to cost in our industry.
Oh, yeah. Definitely less layers. Oh, yeah.
Yeah.
More efficiency and getting the PCBs out. Right. Yeah.
And then one other cool thing we did. So this is a small one. It's the 2x2 millimeter, and it does 4 RGBs. And so that's for customers that want indicator lights or something. Peloton designed this into a few things.
Cool.
So what processor are we using on that one?
This one uses the QtPi SAMD21. And so we programmed it in the Arduino IDE.
Excellent. I like the use of the stomach cable. It's a really good way to plug into it.
Yes.
It's really good play.
So our first attempt was before we hired her. We had like just some regular, header pins, and the wires not reliable.
Yeah, they're
not fun.
Yeah. So we're changing everything. All our boards right now it's soldered in, but we're redesigning all our boards to have this.
Excellent.
Once you go stemma, it's really hard to go back. Once you just quickly, especially for doing the eval boards where you want to constantly switch them out and change them out. Yeah, it's
another thing Chelsea worked on was we changed our color space in our software to be sRGB, so it matches the computer screen colors.
That's
pretty easy. It's just a little math.
Excellent.
So, and then
definitely
we did another board where we bridged 2 chips together into a light bar. Right now it's not lighting everything. It's kind of all white here. This one does. Let's see if I can get it to show colors. It's oversaturating with this camera, but we're doing random colors to random LEDs right now. And so it's just one of our patterns we have. Now we're doing some log breathing.
Oh,
nice.
So, but the patterns go contiguous across multiple chips, and we wrote our software to allow that pretty easily because it's parameterized, and you can put a map of how many chips are on the bus and everything. One other, are you guys still there? Because we see a black screen.
Can you hear us?
We're having a connection problem.
Maybe, yeah.
Yeah, you're right next to us.
Yeah, if you can hear us, keep going.
You're a little choppy, but you came back. We're here.
Can you hear us?
Sounds choppy.
We're having some sort of a connection problem.
Oh no! Yes, live streaming.
Don't worry though. We saw everything you demoed.
Yeah,
it looks really good.
All right, I guess we'll end it here.
Yeah, it looks. We got about 8 minutes, but I think that is everyone.
Oh, all right. Well, thanks, Carl and Chelsea, for coming in. If you folks can still see us.
Yeah, don't worry. We saw.
We can't hear you guys. It's very choppy audio coming through, and there's no video. There's some sort of a network problem going on.
All right. Well, we'll catch you next time, I suppose. But thanks for hanging in there, folks.
Okay, maybe we have to call you guys back in. We'll try that.
All right. It's all good. All right, folks. Well, that's the show and tell. It's a live stream on the internet, and sometimes things like that happen. But thank you, everybody, for coming in. Don't forget, don't go anywhere, because in a couple minutes we'll have Lamar and Phil here. Not here, but over there on this YouTube channel thing. That's it. We're gonna go now. Bye, folks.
See you next week.
Thanks, everybody.